A client sends a post to create something. The server does it. Then the response gets lost on the way back. A timeout, a dropped connection, a dead cell signal. The client has no idea it worked, so it retries. And now you've created the same thing twice. 2 orders, 2 records. On a payments endpoint, 2 charges. The fix is the IETF Idempotency-Key header, still a draft, but already the convention Stripe and Adyen standardized on. And Trellis ships it as built-in middleware, so a retry can never double submit. Here's the trap every right endpoint has. A client posts a new project, Apollo. The server creates it, project 42, and sends back a 201. But the response is lost. The client never sees the 201, so it has no idea the project exists. It does the only safe-looking thing and retries the exact same post. And the server, with no memory of the first one, happily creates it again, project 43. Now you have 2 Apollos. Same request, sent twice, 2 side effects. The fix is 1 header. Before its first attempt, the client generates an Idempotency-Key, a unique value, usually a UUID, for this one logical operation and sends it with the post. The first time, the server runs normally, creates project 42, returns the 201, and quietly captures that whole response against the key. Now the retry, with the same key. Instead of running the handler again, Trellis replays the first response, verbatim, the same 201, the same project 42, and adds an Idempotent-Replayed header so the client knows it's a cached copy. No second project. And the guardrails are strict. Reuse the key with a different body. And it's a 422. Retry while the first is still in flight. And it's a 409 with Retry-After. And wiring it up is almost nothing. At startup, 2 registrations. Add Trellis idempotency for the middleware, and a store. In memory here, but in production a shared one, Redis or your database, so a retry that lands on a different replica still finds the snapshot. Mount the middleware once, then opt in per endpoint. Mark your post with the idempotent attribute, or with metadata and minimal APIs. That's it. Endpoints you don't mark are untouched. Marked ones get the full reserve, replay, and conflict handling for post and patch, because put and delete are already idempotent. You never hand-roll a cache in your handler. The standard semantics are the middleware's job. So an idempotency-key gives you 3 guarantees. 1. The client generates 1 key per logical operation and sends it with the right. The first call executes, and every retry with that key replays. 2. A retry doesn't rerun the handler. It replays the first response, verbatim, the same status and the same body, tagged with Idempotent-Replayed so the client knows. No duplicate, ever. 3. The guardrails are strict. Reuse the key with a different body, and it's a 422. Retry while the first is still in flight, and it's a 409 with Retry-After. And snapshots expire after a TTL, 24 hours by default, after which that key is fresh again. The Idempotency-Key turns a dangerous retry into a safe one. The client attaches a key. Trellis captures the first response and replays it on every retry. And a timeout can never become a double charge or a duplicate record. 2 lines of setup, 1 marker per endpoint, no hand-rolled cache. Next, we read large lists without missing or repeating a single row. Cursor pagination that actually scales. Subscribe, and I'll see you there.